This video will cover area and perimeter in a coordinate plane. The formulas below will be used in the examples. The first one is the area of the triangle, base times height, and ABC are the sides of the triangle. The rectangle, length and width. For the perimeter, you want to take 2 of the lengths and 2 of the widths and add those together. Then we have the distance formula. Make sure you label your coordinates on your coordinate plane. And now we have the final formula, which is Pythagorean Theorem. I'm going to show you 2 ways, the distance formula and Pythagorean Theorem. So the first shape is a triangle, and we're going to use the distance formula for side AB. I'm just going to substitute in the x sub 1, y sub 1, and the x sub 2 and the y sub 2, which will leave me with 5 minus 1 and 2 minus 1. So now once I simplify this, it leaves me with 4 squared plus 1 squared. Simplify it further, 16 plus 1 is the square root of 17. And if I convert it to a decimal, that's approximately 4.1. That's using the distance formula. Now what I'm going to do is enclose this triangle inside of a shape. And then on that shape, I'm creating 3 right triangles. That will allow me to use the Pythagorean Theorem. What I want to do now is I want to count the units to see what the length of the leg of one of my triangles is. That one is 4. And then I want to count the base, doing the same thing. And I see that is 2. And now I want to find the hypotenuse. Again, I could use the distance formula, but this is just another way to do it. I'm going to do the same all the way around. I'm just going to try to find the hypotenuse, which is the sides of the original triangle that was shown. Substituting in for a squared, I'm just going to select one of the triangles for BC. That's the first one that I'm going to start with. So the hypotenuse for BC can be found by using Pythagorean Theorem because that's a right triangle. So I'm going to substitute in the 2 for A, and I'm asked to square it. And I'm going to substitute in the 3 for B, and I'm squaring it. And now, in order to get C by itself, I have to square root both sides because that's the inverse, so I get rid of that. Simplified, 4 plus 9 is going to leave me with the square root of 13, which is approximately 3.6. So I'm going to go ahead and label that side as well because I'm going to need that later on. And then the final side that I will actually try to find for the hypotenuse is side CA using that right triangle. And I'm going to do the same thing. I'm just going to substitute in for A and B and then further simplify. So now I'm going to label this side 4.5. And I have all of the sides that I need. So I have to keep up with that information because I'm going to use it later for my perimeter. But for now, let's go ahead and find the area of the shape that's on the outside. I notice that it's a 4 by 4 shape. So my formula says that I would just multiply the length times the width. So area is going to equal 4 times 4. Therefore, my area is 16 of the outside shape. Now what I want to do is find the area of the 3 highlighted right triangles. It doesn't matter which one that I substitute first. So I'm going to take the 2 and the 4 and I'm going to put it in the place of the base and the height. And then I'm going to take half of that. That leaves me with 4. And then I'm going to do the same thing for each one of the right triangles. So to find the area of the inside triangle, my original triangle, I'm going to take the shape that's on the outside and take the area of it, and I'm going to subtract the areas of the right triangle. When I do so, 16 minus 4 minus 3 minus 2 is equal to 7. I accidentally wrote 9, but I meant 7. 4 plus 3 plus 2 is where the 9 is coming from, but it's really 7. So 16 minus the 9 is 7, and that's going to be the area of my original triangle. So the area is going to be 7 square units. Area is always identified by a square units. So remember I said we needed those numbers for the perimeter? This is where we're going to substitute it in for A, B, and C. And then we're just going to add those numbers together, which will give us the perimeter of the inside triangle of 12.2 units. In example 2, we have a rectangle inside of the coordinate plane. First side we're going to identify as AB. And again, we're just substituting in the x sub 1, x sub 2, so on and so forth. Make sure when you have a negative number that follows a minus sign that you put it in parentheses. And that's going to tell you that you have to actually add those two together. And on the other sides, I'm going to show you the other method. If you chose to use the right triangles on the outside. This time you're creating 4 right triangles. Using the Pythagorean Theorem, I need to have the side measurements of the legs so that I can find the hypotenuse. And as you can see, I'm counting, and I have 8, and I also have a 4. So I'm trying to find the side length, which if it's a rectangle, we know it should be 8.9, but let's just see, because it should be the same as the side that's opposite of it. So substituting in, we're going to put the 4 for A and then square it, and the 8 for B, square that. And the inverse of a square is a square root. So we're going to have to end up square rooting both sides to get C by itself. And as I said, the opposite sides are going to be the same. So I see that side DA and side BC have the same value, 8.9. So now we're counting the units so that we can do the same thing for side CD. And this one is one side is 2 and one side is 4, and we're trying to find the hypotenuse, which we already know what it should be because it's going to be the same as side AB. So both sides were the same. So we're going to find the area by multiplying one of the length times width. So above you will see we have 8.9 times 4.5. Once you multiply that out, it's 40.1 if you actually round it to the tenths as the direction said. So if you did the square root of 80 times the square root of 20, it's exactly 40. So for your perimeter, take 2, multiply 8.9, add it to 2 times 4.5 for 26.8. And those should have had units next to it. Area is units squared, perimeter is units.